I don't necessarily want you to have to lug it to class every day. I know some of you guys just use the ebook and whatever, but we don't have enough books for us to have a class set of books. So I have essentially 2 extra books of what we're using. I have my book, and then I have an extra of it. So we could have those 2 in here. Anyone have any ideas? Because I think we really need like 3 or 4 to effectively have class, even if we share with pairs. Who had been just straight up leaving their book in here? Like you never took it with you, whatever. Yes, that's what I thought. But I don't want them to be left back there because that's going to confuse 7th graders of thinking that's okay. What if we kept your book somewhere else?
Like right there. On the shelf. Every day. Let's put them with the discs.
What if we kept your guys' books?
Yes. That's perfect.
Just like right over here.
What do you mean take
At the end of class, let's try that out. Of just stacking your books right over there. Because it's out of the way, it's next to the other books. Let's try that after class and see how that works. Cool?
Sounds good. Oh, so much better here.
It's what?
Spanish's lights, for some reason, it was just so bright in there, and I couldn't.
Yeah, well, I keep half my lights off. So.
I couldn't keep my eyes open.
All right, so because I heard the question when we came in of like, what the heck were we doing before break? Those reflection angles from the pool table where we talked about the angle of reflection is going to be the same as the angle that it hits. The service box problem that we did with the triangles and the trigonometry and those sort of things. All that sort of stuff, right? And back in 6-1, it was kind of a shift in gears of radical and fractional exponents. Remember that fractional exponents just mean that it is a root as opposed to actually like a power. So an exponent of a half is actually the square root. And then today, we get to help Laura with her sound system.
Go hire some professionals.
So if you've ever looked at Monster speaker cable, it's really expensive. It's really high quality, but it's really expensive. So Sarah's going to run the speaker wire straight to them, right? We don't have to take the 90-degree angle. And speaker A is here, speaker B is there. Don't ask me exactly why they're offset like they are. But there's an 8-foot gap between them, right? This is where the speakers have to be. This is the gap that has to exist between them.
That's like a 4-foot sound system. It's like this big.
Let's go.
So.
Wireless speakers.
Huh?
Wireless speakers.
No. And actually, I would argue that wireless speakers won't give you the same sound quality because when you send things through the air, you're going to lose some quality no matter what. When things go directly through a wire, you get like it gets there more efficiently. Yeah, like if you plug into an internet connection, you'll get a faster speed than if you're just on the wireless. So you have your resource page, and if you really want, you can come up and play with this. Somebody could come up and guide this, and you can play with the sliders here and see what that does for us. We want to find where should this point be to most efficiently, like essentially have the least amount of combined distance with purple and red.
Right smack dab in the middle.
Absolutely not. This is not
Would
going
it be
to
like a little bit to the left of that?
That's for you guys to figure out. So I am done engaging with you for at least a few minutes. I want you guys to dive into this on your own, start playing with options. How could we figure out the most efficient solution to this? And again, I remind you of my favorite professor, Dr. Smith, always saying if you don't know what to do, just do anything. Draw a line, move a point, place. You can, sure, yeah. Be careful that my smartboard apparently got. Oh, that's not damage, that's tape. Somebody taped something to my smartboard, which is also rude.
Wait, why would they?
Because we did breakout. Because we did a breakout.
Wait, you guys got enough breakout?
No, it's like the
Yeah, we did
what's it
breakout
called?
E-
The
breakout
get out of the
boxes.
room thing.
Oh, those.
The thing.
Oh yeah, we did that last year.
Really watch
Yeah.
yourself.
Yeah, it's
I got to do
everybody.
an
Oh
escape.
yeah.
Okay, I don't mind barely being in the
Oh.
Making like
You probably like 4 and 6, and then that would be like.
You got me. I'm guessing.
It's between floor. Okay.
Okay.
Well, it's also because I need to recenter my smart board, I'm sure. No. I did not
You
want to
broke
close
it.
that.
You were.
Well, because
It doesn't tell you the length, and then this one can't.
that would be helpful.
So it would be closer.
I really don't do high diagram.
Like it would have an extra slide or something.
I mean, can we figure out the length of the lines?
Yeah,
Fairly easily.
But we know how to, but it takes a lot of
I
time.
already did a few different.
So what was your checking day?
If you put it
Yes,
all the way,
I
put it all the way over, like right on the sticker speed.
Yeah, so here's like one
14.
option,
That's
right?
14 feet exactly. All the way
Total?
on the speaker A. It is 6 feet plus the square root of 80.
So over here? Where is it?
Yeah.
So Chris has solved both of those. All the way over, all the way over. Which of those is better? Under.
12.81.
I also did 2 in. I also did it at 6.
You did it
Oh.
6.
Yeah, and that's square root of 72 plus.
Which one's your most efficient so far?
Mine
I
was
think 7. I think, yeah.
I would work in decimals, by the way. I would not work in radicals. Your most efficient's 5.
12.81.
What was this? If it's dead in the middle, what was?
It's 4. It's 12.86.
What about over here at 2? Because you did 6.
I did 3.
I remember doing
You did 3.
Yeah. I didn't do 2.
I'll do 4.
I did 12.86.
Can you give me one?
And
I have 4 laptops in the door.
Here, you can have.
What's the shortest distance between 2 points?
What?
What's the
A
shortest?
straight line. I wish we could just put it right there.
So if we could move the stereo.
the stereo can't float.
Yeah, the stereo can't float. And
Okay,
it
okay. So in
won't
the
look
picture,
good.
in the
Hang on,
picture,
into
the
the
speakers
wall.
were hanging against the walls, right?
Staple it
Go
to
back
the
to-
wall.
Just do that with the stereo. Tape it.
Yeah, too bad. So your realistic reasoning behind that is if you're talking about a real stereo, this is really heavy. Amplifiers weigh a lot because how they're made.
You
You-
see what you
so-
have there? The shelf.
It's
Yeah,
like a,
but then you'd have to
That's
buy that,
advanced
and what we're
tape.
trying to do is spend as little money as possible.
That's advanced
So wait,
tape.
hold on. Listen to my question though.
Which is more expensive
So,
than the shelf for the
if we could turn this into a straight line and put the stereo up here between it, right, that would be best for us. But we can't. Is there a way to turn this situation into a straight line? And I am not talking to you anymore. That's just my question to put out there. If we know that the shortest distance between 2 points is a straight line, is there a way to use that knowledge in this situation?
Maybe put like a speaker here, 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 here. No, I don't.
Whoa.
I don't think you can use this.
Physically, in the problem, no, you can't. But by math, you really need to ask a different question.
You just go like this. Or maybe like this.
If you go 16 feet to the
Oh, wait,
right,
no,
you can make a straight line.
You guys are going to be really upset when I,
Right on a can.
no, this is for the next thing that we're doing.
You're gonna
With a
throw
roll.
cans
What's the
and
distance
make
between
a-
the 2 points?
Keep rolling the can.
No!
Stop.
There are
What?
cans.
Please.
Roasted chicken noodle.
What?
So he's gonna like solve
Can I come
all of
up
our
with a board
problems
for
with
this
these
momentum?
Yeah, I
Yeah.
don't care what you do.
Oh yeah.
Oh, there's. If only it
If
would
you
tell
move
us.
it 16 feet to the right, there's a straight line.
16 feet to the right.
But
Yeah,
yeah,
from the speaker B.
but you couldn't do that.
I mean,
But
it's still
Speaker A and speaker B, like, those are fixed distances. And we know that the table here is 6 feet below and 4 feet below. Like those.
Yeah. Like,
I don't think that would make it any shorter.
no, it wouldn't make it any shorter, but then you got a straight line.
Okay, so what you're asking is, if we can't move speaker A, speaker B, or the
We
stairs,
can't physically move it, but if we're just trying to calculate the math, we can do whatever we want for a moment.
okay,
How
'cause
about
that
we
would
just
be
like
impossible.
make a bunch of bricks and just
You can't.
like go through the process of making the bricks? Not like,
What if speaker B wasn't above the cabinet, but instead it was
4
actually
feet below? Ah, that's awful.
It would just be straight.
Whoa.
Wait, 6 or
Wait,
4
would
feet?
that make
Well, I mean,
would that make
it does say on this.
We need like
You
draw
can
it
move
out.
the stereo
Can you do that and then just
We
mark
need to-
where it is?
Yeah.
I mean, it does say
You can
yes,
just
but it's
wherever
above
it crosses.
the
Then you draw a straight line.
But I'm just talking mathematically.
Oh,
right?
it's right there! That's an easy. Oh, that's
It's
an
like
easy.
halfway between.
That's
the
such an
floor
easy
and
way to
the-
find it out.
I was really hoping one of you would figure this out before I had to
Wow,
take it.
okay.
What? Well, you didn't. I had to take it there.
Yeah, thank you.
No, but I thought you were like saying, wow, Sasha figured it out.
So if
So it's a little less than
if you hypothetically, are you gonna open or not? Come on, presenter.
I get that same problem with Subnautica.
If we hypothetically move speaker A to 6 feet below the cabinet and try to connect it with speaker B, or move speaker B hypothetically for a moment,
They cross the same point.
we can create a straight line. Right?
Oh, A.
Because of reflection.
reflection.
You know, this is 4.
I mean, technically, like if we're thinking about this, like actually, like
Wow,
speaker
that's
wiring and stuff. What you have to do?
Yeah, your stuff's right there, Ava. I still have class today. You guys don't have math, but 8th grade still does.
You just change it, that's cheap.
Wait, they don't
So your question then down here becomes, how do I deal with these sides? Like this all the way across is 8 feet. But if I'm going to do... Well, what are we actually going to do now? What does this tell me? Why does this help me?
And then you know the point where you're gonna put the thing.
So we know this angle and this angle are congruent. And then... What?
And then the other two angles that are also there are also congruent.
Oh, so these...
What?
So what did we really make?
Straight
It's a,
line,
bisector.
it's also congruent.
Not a bisector.
Straight line, it's also not a straight.
76 sector.
That's weird.
What's the relationship between these two triangles?
They are
similar.
very.
They're similar now, right?
What? I win. I thought he was gonna say the angles.
They're similar in straight lines.
Aha.
So
Then we know
if
the distance
these
is like something.
are similar,
Ooh, can I-
And they're also
yeah, you want to come up and I mean, we still need to figure out. We only know 2 things right now, and then 8. But 8 isn't actually a number that I can use.
Wait, what?
Green doesn't
Oh no,
work
it does work.
Why doesn't green work?
because green's a broken 10.
So
Wait,
now these are the same sides of the similar triangle. So, and since we know they're similar in this one.
Is it just super off? Here, we might need to just totally reorient.
Here.
Chris, stop for a moment.
So,
Let's reorient real fast.
I love this game. How does the pin get dull?
Because the tip of it is like some sort of compressed felt or something like that.
Well, you didn't swear to book mode. How old are these boards?
Mine is the oldest, and I'm not even sure. It has been here longer than me. I have been here 7 years. All right, continue.
okay, so these two angles are also congruent, and that's not too much. But that means that they're similar triangles, and we can figure it out with the ratio.
What ratios?
Like
We only know 2 numbers.
4 to 6, yeah.
Okay, how does that help me figure out this location?
No, it doesn't.
Anybody else have?
I don't know.
We only know two. Well, we kind of know three quantities. We know 8, but I can't use 8.
You can guess like that.
Or no, wait.
Yes.
Could you do 40% of 8?
40%.
That's like the ratio 4 and 6, and then that would have to stay true with the rest.
They are
4 to 6 doesn't make 40%. 4 to 10 makes 40%, but
Are the lengths at the bottom 4.8 and 52?
but how'd you get there? Don't say guess, Jeff.
Yes.
Yes. Oh. God.
If I make this x, right? Because we don't know what it is. What does that make this?
1.8 minus x.
8 minus x.
8 minus x.
90.
Because we know 8, and we want to use that because we know it. So then, if I set up 6 compared to my 8 minus x equal to 4 compared to just my x, we can cross multiply and solve because the similar triangles share parts of that 8. Similarly, if this was x, this would be 8 minus x, and then it would just change what our x would come out to be.
X equals 3.2.
So we are 3.2 away from the right speaker, 4.8 away from the left.
It was because earlier when I asked you, it was 2/3 of 5, and then you said 3.2. I tried that. So
I got it right.
Does that make sense? For a way that we could manipulate that situation? Because really, the speaker is still up there. But we now know that this line, this hypotenuse, would essentially just be running straight up instead of straight down. So, do you realize that this is our pool table problem? That so we're still extending that same idea of if this angle of reflection, quote unquote, is the same as the angle that it impacts, it's the pool table problem. Relating those similar triangles again. And the edge of our pool table that we knew the entire.
And it's 47.
Alright, changing gears. Pushing the clutch. Get ready. Anyone here actually know how to drive a car?
You
That makes
press
sense.
the pedal and then you press the pedal and you go like.
Are you talking about a
Dude,
manual gear shift or an
Yeah,
automatic?
because that's why I said pushing the clutch.
What about
Push your
the
clutch, shifting to drive, then push the gas pedal, and then you can start going.
So,
You gotta do all like
just to pull this all back together, and we're not really going to do this next problem, but if you remember back to, I forget what chapter it was, that we did the whole, are you getting sleepy, the hypnotist problem where we're going to make somebody, actually, we also did one that was cluck like a chicken, where it was you could hypnotize somebody through the mirror, right, on the floor.
Oh yeah.
So wrapping this all together, we knew, and we've shown this a few different ways, but we knew that we could figure that out based off certain distances, right? Making those similar triangles, and we had people with different heights, that's going to determine how far away you are. Same ideas coming back around. Okay? So when you see a problem, and we all got stuck with this, the first time I tried this problem, I got stuck with it. You were functionally fixed at looking at the two triangles standing the same direction. Let yourself make the math easier. If we flip speaker B down below, it's just a straight line problem. So if we look at problem 70, Bradley enjoys not only math, but soup. So Bradley notices that there's 2 points on a soup can, and he's like, you know what? I wonder what the distance between those points is. And you can't go through the soup can. Right? Now, this, if you want to know why we would talk about problems like this, this is actually what designers deal with when they're changing the label on a soup can, or when Progresso goes to put this reduced sodium, or when they decide to make their, the measured distance through the can here would not be the actual size on the label, right? Because it's not what it's saying. So when we look at a problem like this, or extending to the idea of what if we look at the problem in part B, where we have a cube, we're trying to find shortest distance. How can we figure this out. Questions?
Can you take a stick, stab through the can?
We're not. We don't want the straight line distance, like through the. I want to know the physical distance from A to B.
So can you take a stick, bend it over, mark it
Take off the
out?
label and fly it.
It doesn't work like that. Okay, you bend it
Make one of
stick.
those bendy rulers.
Bendy ruler.
If you look at the can, can you measure the distance between A and B, just like this, where the points are, like 3D? So like you measure between them here and there, right? So like
My ruler's flat.
no, when you do that, like you do it like this.
The one that
Bendy
closes
this,
your
you're
ruler.
doing that.
The thing that closes
And then
these is,
you,
like numbers that's like
Draw this, and you put this is the surface of the can, and here's point A and point B, and then this is the straight distance, and then you can figure that out.
Bro, use the tape measure.
You saying someone use like a parabola or something like
You
that?
could do
No, you could make it like a net. Okay, like you could like. Okay, I was from his idea where you could just say take the label off. You could just like, I don't know how to unfold it. So what you could do is like you could take the label off, then you could measure these. You could put it here.
I like your thinking. Yeah, that thinking, right?
Also, right underneath this.
Yeah.
It's like, yeah, that's my lunch.
Not maybe in my lunch today, but it is my lunch. So net thinking, right? So what Jacob essentially is saying is, well, the easiest way to deal with this is just
Stab stick.
take the label off.
the easiest way is to get a tape
Actually, no, bendy rulers are better.
measure. Okay.
Because tape measures have that little like metal thing at the end, and they sometimes
It's extremely frustrating
Why?
It's like we're
because it won't break.
It's like we're trying to open up a lack of happy.
It
It sticks to the wrap.
So if we take our label
They're
off,
pretty easy actually.
Unless
like,
they're
throw that out.
no, unless
It
they're
depends
melted,
how
and
you
then they
take them
stick
off.
to the wrap.
now hold up. Here's the problem though. Sure, I can take the label off of this, but what if it wasn't on a label? What if it was on the physical can?
Rip the can apart.
No.
Now I don't know if you've ever cut
We
a
are the
metal can,
math
but
gods.
once
We
you
can do
bend-
whatever we want.
once you bend metal, especially once it's been corrugated, this is
Knife
called
hand
corrugation.
Oh.
It would be pretty close to impossible to actually flatten this back out to flat. So what are some other mathematical strategies that we could use to deal with, like, say we actually
Hydraulic
physically,
presses.
so put this in the realm of the real world. If we're measuring distance between 2 points on the Earth, we're not actually measuring a straight line. You're measuring a straight distance, quote unquote, whatever, but you're on a curve. You're on a curved object, right? So how could we deal with this if it's physically on the can?
Oh, so to be. Never mind, crystal it.
So keep that idea in the back of your head. I'm trying to manage time well. And start thinking about part B. If the shape was a cube, and we wanted to find the shortest distance between C and D, but the actual distance on the edge of the cube, so you can't go through the cube, we want to make a line connecting C and D.
Oh. You mean
Yeah,
that's
C and D.
things in 3D.
Not C and D. Like
So that's a cube, right?
Wait,
So
did
that-
you just meet the point closest to
Go
C
to
and
diagonal and
D?
then go to that.
Or like, what do you ask?
Can
So-
we make a cube and then look at it?
have
You
a
just
cube.
have a net.
You can.
Nope. I
So
want
if you go from this corner to this corner,
You can't go through the cube. You have to go on the surface. Yeah,
You
it'll be
have
like
to go on
you
the
go in the
surface.
middle.
You go on a diagonal line.
Yeah, like that. No, you wouldn't. No.
It would be quicker to go through the middle instead of going.
No,
like
you
from
can't
here.
go through
you can't go through the cube.
No, you go on this side of the space and then go on that.
Yeah, no. What you do is you go from here then to there,
It would.
like this.
Oh yeah, like the one problem
that
is
and then going
yeah,
back
it could be
on
that.
Can you prove it?
That, and then that.
Can you justify with like a picture?
Here, draw a cube.
So let's say, here's where we'll really give it some numbers. Let's say this cube is a 3 by 3 by 3, right? It's a 3 cube. What is the distance on the surface to get from C to D? Shortest we can make, but you cannot go through the cube. So there's your problem. If it's a 3 by 3 by 3,
It's so annoying.
you want me to do it? Yeah, I know. You just have to deal with the fact that it's going to be like annoying.
Similar, my drawing doesn't suck.
That's hard to imagine, but okay.
Oh.
Use your graph paper.
I have
Oh, it's six radical 2.
Wait, hold up.
It's 6 radical 2. Is it?
6.7. I found a 6.7.
I'm still making myself a.
Wait, I'm gonna look up what 6 radical 2 is.
You have a calculator.
Sorry, I'm going to find out.
Calculate, compute,
Computer.
pick better words.
Computadora.
But you guys
Do.
I got
Radical
I don't know if they're
11.25 plus
I need to
radical.
get this out.
That's right, I think.
I got 6.
I said 6 radical 2 and it just straight up gave you 6 radical
plus
2.
radical 11 points. Go to the teacher mode.
What should I put in? Classic or?
So,
Yeah, okay, Mr. Hudson.
Yeah.
How about okay,
Yeah.
thanks. How about 6 radical 2 and
Yeah.
it gave me
Because
6
you're a
radical
math
2.
cramp.
Hold on.
You need to go change your mode.
You said
And I'm not going to explain it to you again. I'm going to let you figure it out so you retain this knowledge.
Two
that
little
is-
arrow buttons. Two little arrow buttons that are going opposite from each other. Press that, and it'll go into the right place.
So I think most of us pretty quickly got to this same idea of we're going to take a diagonal line and another diagonal line.
Yep.
But if we want to make our life really easy, we can determine, well, both of these will be the same since it's a cube. And then if we really think about it as just one line, it's just one right triangle, right?
Yeah.
So this edge is 3, this edge is 6,
Wait, what? You said it was a 3.
Yeah,
this
that's
3. So
1.5.
again, you're selectively listening. We're going to make our life as easy as possible. I'm not asking about this distance.
Oh.
I'm asking about this triangle.
Oh.
Because this triangle is 6 by 3. And it's right, and I can solve it pretty easily.
so we just need to use Pythagoras
You do need to use Pythagoras.
to find the distance.
It's a radical 45.
And then we got it.
Yes, it's radical 45 and 6.
6.708.
Then we need to find where to draw the line.
We already
No, you draw it from that corner to like half of that.
You just do it in the middle.
basically we make a net, and then we just
Why? No.
But the question is, how do you make a net?
Until it turns into
Going back,
yeah.
because then I want to give you the last like 10 minutes to work on your homework. Going back to the soup can question, 2 really easy solutions actually. 1, tracing paper. 2, string. So I know they're not very creative, but if we're talking about math tools that you have at your disposal, any object that can be used to measure, not measure like with numbers, but just measure.
Well, how did you do that?
You're intentionally
You're like,
holding it like wrong.
No, he took. Okay, so I folded it wrong. See if it would go in. He said it would go in that way, so I folded it the other way.
yeah.
Remember that game where
Tried to do it
you
inside
gotta put
out.
the square peg into the
In the
square
square
hole,
hole.
and the circle peg into
You
the
literally
circle
tried to go
hole,
like this.
and the
No, but he said
triangle
that I was doing it the wrong
peg.
way.
Yeah,
so I
so-
flipped it around. He did
So I need your attention, because then we come back to these problems, and it's like, Satya, I swear I already said this, but your brain is focused on something else when I'm teaching the thing that I want you to know. You know what I mean? So, don't always, and I figured this would be a good lesson as we transition back from winter break, don't always let your brain go super deep, super fast. Like, sometimes the easiest solution is get a piece of string. Get a piece of tracing paper. Lay out the net. What? But what?
Yeah.
I thought we were actually trying to solve it.
So theoretically, like we can do, like we can theoretically move the speaker, right, and make that a straight line. No,
I
because
hate
if
the
you
word
guys had said,
theoretically.
do you have a string? I would say yes. Fantastic.
What if
And
I
did.
use the wire that I bought to like
Why?
do
Do you
the
keep
thing?
that in
But you
your
didn't
desk
buy any
just
extra
for
because we
moments
calculated exactly what we needed.
No, I'm cutting.
All right,
away
last
what I
8
need.
minutes you got for homework. So here you go. Let's get started on stuff.
Homework.